All right, so in this set we're going to look at combinations of transformations and how we can put it all together from the previous two sets into one question. So you'll start to see questions where it gives you multiple transformations and it will expect you to put them together into one combination. All right, so things to remember. You need to remember that we have translations and dilations. You need to remember what they do. So translations will add onto x and y values. Dilations will multiply onto x and y values. And then you need to remember which directions things will happen. So from the x-axis is a vertical change. From the y-axis is a horizontal change. All right, so from x, from y. And other than that, if you want to go back and have a look at your notes from those couple of lessons, I'd do that before we go any further. All right, so we'll start by looking at a point, and if you're looking at your textbook, we'll have this example. It says that you've got, first of all, you've got a dilation of 2 from x, and then you've got a reflection in x, so a reflection across the x-axis. All right, so that means it's moving up or down. So your first step is to draw or list a point. So you've got x, y, and then we'll apply this change to it. So maps to is the arrow, or yields. It doesn't really make a difference, but maps to fits with this context. So a dilation of 2 from the x. So remember, from the x is a vertical change, so it affects the y value. So we've got 2y like that. And then we've got this change to have happen, which is a reflection in the x-axis, and that is also a vertical change. So it's going to look like this. So our point has been stretched by a factor of 2 away from the x-axis, and then it's been moved vertically over the x-axis. For example, a point might be 1, 1, all right, and then it's been stretched away, so the new point is 1, 2, and then it's been reflected across the x-axis, so the new point is now 1, minus 2. So this is the combination of these two transformations to this point. All right. So remember, things you want to do for yourself is to set it out like this. This really, really helps to put your transformations in order. So first one, then second one, and this is the part that you're now wanting to set equal to your image. And if you were given a rule, you would use this to help you work out what the new rule would be, which we'll get to in a few minutes, so don't stress. Another example here, so we'll have dilation 2 from x-axis again, and then we'll have translation 2 units positive x direction, which is right, and then a translation 3 units negative direction of the y. So positive x direction is right, we'll put that there. Negative y is down, so we'll put that there. All right, so we've got 3 changes to make here. So again, we'll draw up our point, which is xy. All right, we'll map it to the first one, which is a dilation of 2 from the x. So remember, from the x is a vertical change, so it's going to be x, 2y. Then we'll map it to a translation of 2 units right, and that's a horizontal change, so that maps to the x value. So we've got x plus 2, 2y. And then the last one is this translation 3 of the negative y. So that maps to the y value. So we've got x plus 2, 2y, take 3, because 2y was already in the question. So I'll just erase this and I'll write it on the next line down. So x plus 2, because that's been translated 2 right, and then 2y, because that was the original change. And whatever 2y is, we're going to translate it 3 units down. So it just looks like that. So the first change that happens is the dilation, then the translation. And this is a really interesting thing to have happen. So I'll just expand on it a bit more, I've numbered the transformations that happen in the initial part. I've got 1, 2, and 3. I'm going to do them in a different order just to show you the difference that it can make. So we might do transformation 3 first, then we'll do transformation 1, and then we'll do transformation 2. All right, so first of all, set out your point. You've got x, comma, y. And then I'm going to do transformation 3, which was a translation of 3 units in the negative y direction. And you might remember that that happens to the y value. So it's been translated first. Then I'm going to do number 1, which was a dilation of 2 from the x. Now from the x, dilation is a vertical change, so that happens to the y value as well. So it's going to be x, comma, 2. Now, this is where it gets interesting because I have to use this y minus 3 as part of the change. All right, so we'll leave that there for now. We'll do transformation number 2. Translation 2 units in the positive x direction, so that's going to translate into x plus 2, comma, 2 bracket y plus 3. All right, now, of course, we don't leave brackets unexpanded, so we'll just simplify these brackets. The first one is still x plus 2. Then we've got 2y plus 6. So let's go back and compare. In the original problem, the transformation that happened, or the end result, was x plus 2, comma, 2y minus 3. Oops, that should be a minus there in these brackets, shouldn't it? That's a minus there and a minus there. I'll just erase it so we can see it clearly. All right, so you can see here that because of the order that it happened in, the dilation has remained the same, but the transformation vertically has changed. So originally it was given to us as 3 units down, but because it happened at the end, it stayed like that. But if we'd done 3 units down at the start, by the end it would have been 6 units down. All right, so this is where order of operations is vitally important, and the order of transformations you must follow, because if you don't, the question will come out incorrect. All right, now again from the book, we're just going to do another example, but this time it's going to use a rule. So instead of just a point, it's going to use a rule. So first of all, we've got dilation factor 2 from the x, followed by a reflection in the x-axis. So this is essentially the same as the first example we did. All right, and we'll apply it to the rule now. So first step is to set out your image and original point. So you've got x image equals the original x, and the image of y equals 2y, or minus 2y, wasn't it? If you look back at what you had in the original problem, you'll see that it went like this. All right, that was the end result of the transformations. So now we're going to rearrange this one into y equals, so it's going to look like this, y image over minus 2, and it's going to be just minus a half y image, which you can see is the minus a half, or just a half, is the inverse of multiplying by 2. We're multiplying by a half. All right, and then we're going to substitute this and this in place of x and y in, oh sorry, not this one, this in place of x and y in the rule y equals root x. All right, so now we have y equals minus a half y image, which is equal to x image. All right, so we've substituted in those values that we know. We'll multiply this to the other side, so we end up with y image equals minus 2 x image, and you notice that it's now back to being minus 2, and it's outside the square root sign. So the end result is that the rule is minus 2 root x, which fits with what we know, because a negative sign out the front here shows a reflection, this number here shows a dilation, and nothing has changed to the x value. All right, so now we'll have a look at the second example. So a dilation factor of 2 from the x-axis, followed by a translation of 2 units in the positive direction of the x-axis, and 3 units in the negative direction of the y-axis. So again, the same transformations that happened in the first instance, but now applied to the rule y equals root x. So if you remember back to the first instance we had the end result of the point was 2y minus 3. All right, and this was equal to x image and y image. So x image equaled the original plus 2, and y image equaled 2y minus 3. So now I'll go and rearrange both of these into x equals and y equals. So I end up with x image minus 2 equals x, and this one's going to be a little more complex. It's going to be y image plus 3 all over 2 equals y. Then I'm going to go and substitute that and that into the rule in place of x and y. So the rule was y equals root x. I'm going to plug in y image plus 3 over 2 equals root x minus 2. Don't forget the images. All right, now one step at a time, let's get y image by itself. So we'll multiply the 2 to the other side, so it becomes y image plus 3 equals 2 root x image minus 2. Then I'll subtract 3 and I'll get y image equals 2 root x image minus 2 minus 3. All right, so that is the final rule. I'll write it a bit bigger here so we can investigate it to make sure that what we know happened did indeed happen. Okay, so just to investigate, we know from the information that there was a dilation factor. That is our A value, so that shows dilation. We know from the information that there was a translation along the x-axis, which is what this h value shows. It said that it was a translation right, and we read the opposite of this, so that's positive 2, so that is definitely right. And then the other translation was 3 units negative y, which is this one here, which is the k value. So the information we knew has been able to be put into the equation in the right spots. And yes, we could have done it from the very start. We could have just gone straight to using the general form of the equation and substituting values in. All right, and that's where I'd like you to get to. But using this method here of finding the image point and the transformations that happen to each point is a really important step, because later on it becomes necessary to do that. So don't jump straight to doing this. Do try and work your way through image points, because you will need it later on.